calculator is resting on a surface and it's not slipping. You're slowly raising the surface, maybe, I don't know, if it's on a binder or something and the binder's being lifted up. And then when it's at 40 degrees, it just begins to slide. So you take that as sort of the limiting, the point where static friction becomes sliding friction. So you can take that point, this angle of 40 degrees is considered the maximum angle before sliding. Okay, so remember when we talked about friction, static friction, force of static friction, we said it's less than or equal to mu Fn. What that means is if the angle is 0, static friction will be 0, but if the angle is like 10, 20, 30, static friction is getting bigger and bigger as necessary, but the biggest it can get is mu Fn. It can't get bigger than that. So let's look at the forces acting on it, and it's kind of the same as what we've been talking about. There's force of gravity, there's the normal force, and there's friction, right? So we've got these three forces, same as in the previous problem, and we're just going to figure out how they all work together. The difference in this case is that A equals 0. We're still treating it like it's not sliding when it's at its maximum point. So along the plane, we can say that A equals 0, but MA still equals the sum of the forces. So 0 equals, along the plane we've got FGX minus Fn. I haven't drawn it in this time. We can, I mean, what I'm hoping is with the repetition that you're doing, they're starting to feel a little, like you're starting to get this a little bit easier now. So we know then that FGX is just going to be mg sine theta, and that Fn is mu, sorry, this is not Fn, this is Ff. So FGX, what did I do here? This is Ff, sorry. So FGX minus the force of friction, not the normal force. And then this is mu Fn here. So that's the Fn. So then what we can say is, we're looking for mu, really. So we need to know, we know the mass, we know g, we know theta. So then, I mean, thinking about what Fn equals, we've done this before, but we went perpendicular to slope. We saw that Ma equals the sum of the forces. Again, it's 0 because it's not moving, not sliding, is equal to Fn minus Fgx, or sorry, Fgy. So then we know that Fn is equal to Fgy, therefore Fn equals mg cosine theta. So back to this, we've got 0 equals mg sine theta minus mu mg cosine theta. So again, you can see that if you leave the variables in, it doesn't even matter what the mass is because it's going to cancel out. We know that theta equals 40, so we can just substitute. We're going to solve this for mu. Mu equals mg sine theta divided by mg cos theta. So that cancels. Mu just equals tan theta. And this is similar to a problem you'll see in the future, but then we can just say theta equals, or actually we don't even need that because we're trying to solve for mu. So let me see if I can erase this unerasable marker. This is just going to equal tan of 40. So putting that in, tangent of 40 is equal to 0.84. 0.84 is my coefficient that I need in order to, for this problem to make sense.